Suppose if the charge is positive charge, then it is away from the charge. Electric field of that own charge doesn't act upon it. Instead, the external field acts on the certain charge, probably that is Q1. So it is subdivided into three types, that is potential due to a single charge, potential due to system of two charges, and potential due to system of three charges. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 2 of chapter 2, and chapter name is Electrostatic Potential and Capacitance. So in the last session, we had done the introductory concept of this chapter. So in this session, let us just get a little bit deep inside this topic. That is, in today's topic, we are dealing with the potential, equipotential surface, what is meant by potential gradient, relationship between the potential as well as the electric field, and potential due to external field. So these are the concepts which we will study under this session. So first of all, moving on to equipotential surface. What is meant by equipotential surface? As the word itself tells, equipotential surface. It is nothing but the surface which contains equal values of potential. Okay, that means the potential which lies on the surface are having equal values. That is, each and every potential which is on the surface is the same. It has got a constant value. So what is equipotential surface? Equipotential surface is a surface with constant value of potential at all the points. Okay, so that is meant by equipotential surface. Suppose if you consider a point charge, I'll just consider a point charge. So how will you give the equipotential surface to this point charge? Suppose if we have got a point, so the equipotential surface over this charge is represented by a concentric circles. Okay, so what is equipotential? The potential which lies on the surface at all points. So for a point, the surface is nothing but the circles, that is a concentric circle. So how do you represent for a point charge the equipotential surface? It is with the help of a concentric circle. So how is the flow of electric field to a point charge? The flow of electric field to a point charge is always radial. Radial can also be called as normal, or which is at 90 degrees. So this is a point charge for which the electric field is radial. It is radial everywhere. Okay. Suppose if the charge is positive charge, then it is away from the charge. Suppose if your charge is negative charge, then this arrow should be towards the charge. So this is all about the point charge as well as the equipotential definition on the surface. So what is meant by equipotential surface? It is nothing but the surface which has equal value of potentials at all points. That is known as equipotential surface. It is so very clear that having the word equipotential surface, you can easily get the definition. What is meant by equipotential surface? I am repeating once again. It is the surface which is having constant value, that is equal value of potentials throughout its surface at all points. Okay, this is how you learn the definition. So next, going on to, it is relationship between electric field and the potential. In order to get its relation, we are considering a diagram, and that diagram is, consider a thin plate like a structure. There are two plates like a structure, okay. So here there is a point P. So suppose if this is a point P, wherein this plate is known as A and this plate is known as B, and the perpendicular distance from point P to the other plate is said to be dr, and the electric field is upwards. Potential at A is V and the potential at plate B is V minus dV. So these two are the potentials and this is the electric field. Now what is our work? We have to equate electric field and potential. So now consider two equipotential surfaces known as A and B, which is having potentials V and V minus dV, and the flow of electric field is mentioned with the help of E vector through the equipotential surface. So now what is our work? We'll have to consider the work done. That means the work done in bringing unit positive charge from one point to the other. That is from point P somewhere at the equipotential surface B to point A. So in order to calculate that, it is the work done in bringing unit positive charge from this point to the other point is said to be force into displacement which is being taken. Work done is given as, what is the force which is applied over here? It is the electric field. Electric field is a kind of force over here. So I just consider electric field E into what is the displacement in order to bring the charge from this point to this point, it is dr. So taking its magnitude, I have E into dr into cos theta. Since the electric field is upwards and you're taking the charge downwards over here, so I can just give this theta as 180 degree, which is along the line over here. So cos theta means it is E into dr of cos 180 degree. It is minus of E into dr. So dw, negative sign, indicates that the work is done against the electric field, okay, against the electric field. So this is the work done in bringing unit positive charge from one point to the other point in this equipotential surface. So if this is our work done, now our duty is to calculate the potential difference between two equipotential surface. So in order to calculate the potential difference between two equipotential surface, we have total is V is equal to VA minus VB. You're checking the potential difference of the equipotential surface, which is equal to what is the potential of the first plate, that is A plate. It is just V minus, and VB is V minus dV. So I get V minus V plus dV minus V plus V gets cancelled. So what remains is V is equal to dV. Okay, so dW is equal to minus E into dr. This is the work done in getting unit positive charge from one point to the other point, and we have the potential as dV. So we have the work done in getting the unit positive charge. Now it is, when the work is done, there is a potential, certain potentials on the equipotential surface. Which are those? That is potential at plate B. You will have to subtract with the potential at the plate B. Okay. So how do you give this? It is V minus V plus dV. On solving, VV cancels, dV remains. So dW will be equal to dV. So this can be called as equation 1 and this can be called as equation 2. So now you will have to work on both the equation 1 and 2, and it's like equating 1 and 2, you have minus E into dr is equal to dV. So what was our question? We have to relate between electric field and potential. So I have got electric field E, let me retain it here itself, which is equal to, take your dr towards the denominator. So it becomes dV divided by dr and negative of the sign. The potential always acts against the electric field. So this is the one which gives the relationship between electric field and potential. It is so very clear in the session 1 I had told you. The electric work done is always against the field which is applied. So work done in bringing certain charge from one point to the other point is always known as a potential. So when it is a potential, potential acts always against the electric field, which is given by this negative sign. Okay, so that is all about this concept. So what is meant by potential gradient? Potential gradient means it is nothing but E is equal to minus dV divided by dr. The previous equation, whichever we had got the answer as the relationship between the electric field as well as the potential, is nothing but potential gradient. So how the potential gradient is defined? It is the magnitude, that is the value, magnitude of change. D or delta means it is always a change. It is a magnitude of change in potential per unit displacement, which is mentioned over here, dr, per unit displacement, normal to the equipotential surface. Displacement is normal to the equipotential surface, which is given in this diagram. It is normal, that means it is perpendicular to this surface, equipotential surface, which is at 90 degree over here. Okay, so it is the magnitude of change in potential per unit displacement normal to the equipotential surface is known as potential gradient. Okay, so this is all about your definition of potential gradient. Now we are moving on to potential energy of a system of charges. So what is meant by potential energy due to system of charges or of system of charges? We have got one charge, that is Q1. Okay, so work done in bringing the unit positive charge from infinity to a point. Okay, this is a unit positive charge. From infinity, somewhere we are getting to this point. Okay, so this is known as a potential. Okay, so now we have got Q2 charge. Again, the Q2 charge is also brought from some infinite place to certain point. Okay, so the external field alone acts on the certain charges and not its own field. Suppose Q1 is having certain electric field in it, but electric field of that own charge doesn't act upon it. Instead, the external field acts on the certain charge, probably that is Q1. Okay, external charge means Q2 acts on Q1, or else on Q2, Q1 is supposed to act, but not Q2's field doesn't act on itself. Okay, so now we have got system of two charges. Suppose you consider these two charges. When you consider these two charges, your equation, that is the potential due to one charge on the other charge, becomes V, and the distance of separation of two charges, call it as 1 and 2, so R1, 2. You can just call it as the potential V is equal to 1 by 4 pi epsilon naught. The potential on Q2 by Q1 can be given as Q1 Q2 divided by R1 2. So this is only due to system of two charges. Okay. So now when there is a other charge, how is the existence of other charge now? That is, the charge is brought from some point infinity to other point. Okay. So somewhere from infinity charge Q3 is said to be brought. Now when you just join all these points, so there is influence of this neighboring charge on Q3 and this neighboring charge Q2 on Q3. So the distance between Q1 and Q3 is said to be R13 and the distance between Q2 and Q3 is said to be R2 and 3. Okay, so this is a system of charges which we are considering, system of three charges. So now when this is a case, what happens? That is, this had got influence on this and this charge had got influence of this, which is being written over here. System of two charges. Okay. So now Q3 is the charge which is having the influence on of two other charges, that is Q1 and Q2. But the influence of itself doesn't happen anytime. Q3, the field acting on Q3 will be either from Q1 or Q2 but not from Q3 itself. So how is the equation you're supposed to write? So it is V is equal to, suppose if this is V1 and this is V2, the second equation can be written as, that is, on Q3, Q1 acts first, so it can be 1 by 4 pi epsilon naught. Q1 is acted upon Q3 divided by the distance between two is R13. Okay, and Q2 is also acting on Q3, so it becomes plus 1 by 4 pi epsilon naught. Q2 acted upon Q3, which is divided by the distance between two charges is R23. Okay. Similarly, it goes up till 4th charge, 5th charge, till the n number of charges. Okay. So now we will have to sum up all this. That is, total potential is equal to V1 plus V2. Suppose if you are summing up like this, you will have the equation 1 by 4 pi epsilon naught Q1 Q2 divided by R13 plus, you will have to sum up all these, that is 1 by 4 pi epsilon naught Q1 Q3 divided by R13 plus 1 by 4 pi epsilon naught Q2 Q3 divided by R23. This is the potentials due to system of charges and it goes on, which will be equated in case of summation. So this is all about this derivation, which is a concept for you to understand. It is not like this is important and it comes for the exam, but you will have to understanding this concept is very much essential for the further applications of the same chapter. So now moving on to potential energy in an external electric field. So it is subdivided into three types, that is potential due to a single charge, potential due to system of two charges and potential due to system of three charges. So this is subdivided into three types, that is potential energy due to a single charge, potential energy due to two charges and finally it is potential energy due to the dipole. Okay. So now we are considering first one, that is potential energy due to a single charge. Potential energy due to a single charge. Suppose if there is a charge Q, so the work done in bringing a unit positive charge from infinity to a point is said to be what? It is a electric potential. So how do you just give that? It is work done in getting a unit positive charge from one point to the other point or infinity to a point. It can be given as W is equal to Q into V. Okay, because the potential is, since we know that what is potential, it is work done in getting unit charge from infinity to a point. So when you just cross it, it will become W is equal to Q into V. So when you have this equation, it means to say that the Q charge has got the influence of external electric field but not its own electric field. Okay, so Q charge, the charge Q acts on the influence of only the external electric field. So suppose if this is a potential, in order to get the charge Q from one point to the other point, we have U is equal to Q into V. We can replace this W by the potential, that is U. Okay. So having this, you can easily define 1 electron volt concept. So 1 electron volt in the sense, suppose if you have a charge Q is equal to 1.6 into 10 to the power of minus 19 coulomb and potential of 1 volt, then how do you define 1 electron volt? So 1 electron volt's value will be 1.6 into 10 to the power of minus 19 coulomb. So this is all about your 1 electron volt. So how can you define it? When a particle is accelerated, particle of charge Q, which is having the value of 1.6 into 10 to the power of minus 19 coulomb charge, is accelerated at a potential of dV. Suppose this has to be dV. So suppose if a charge Q is accelerated at a potential of dV, then this event is said to be 1 electron volt or a electron volt. So 1 electron volt means it is the charge with 1.6 into 10 to the power of minus 19 coulomb, and this potential, change in potential will be 1 volt. Then you can term 1 electron volt. That is, the particle is getting accelerated with dV, change in potential. Okay, so that is all about your potential energy due to a single charge, wherein 1 electron concept is introduced. So you will have to learn what is meant by 1 electron volt or define 1 electron volt from this concept. So next, coming on to the potential due to two charges. Now we studied about single charges, and now coming up is the potential energy due to two charge. So now the second one, potential energy due to two charges. So as I told you previously, for the potential energy due to system of charges, the charges are got from infinite position to a certain point. So suppose if you have got two charges over here, Q1 charge and Q2 charge, which is separated at a distance, call it as R, then how do you give the potential energy due to two charges? It is nothing but, suppose if you consider this potential energy of yours as U, which is equal to 1 by 4 pi epsilon naught, there is influence of Q1 on Q2 and Q2 on Q1, but not Q1 on itself or Q2 on itself. Suppose you consider two charges, Q1 charge and Q2 charge, which is separated by a distance R, then the work done in bringing unit positive charge from one point to the other, that is, if you just consider for this Q1 charge, the work done can be given as Q1V1. Okay, so the work done for the second charge, if this is W1 and W2, for the other charge it will be Q2V2. These are the work done in bringing the charges from infinite to certain point. And suppose if you have got a potential, that is potential, the work done on this Q2 due to this Q1 can be given as, by the potential, it can be given as 1 by 4 pi epsilon naught Q1 Q2 divided by R. But the total work done by this system of charges can be given as W is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R plus Q1 V1 plus Q2 V2. So this is the total work done by the two charges. Okay, so that is all about your potential energy due to two charges. You can just replace your work done by U. That is the potential energy. Now moving on to the other concept, that is potential energy due to dipole charges. In today's class, you have studied the concept of equipotential surface, potential gradient and potential due to system of charges in a single potential energy in a single charge, potential energy in the two charges, and coming on to the next concept, that is electrostatics in conductor, and as well as the detailed study of capacitors and Van de Graaff generators will be studied in the next upcoming classes. Until then, have a good day. Thank you.